Hello, everyone. We're still working through Chapter 3, Assessing Significance in a Fourfold Table from Statistical Methods for Rates and Proportions. We're working on Section 3.2, the exact analysis of a fourfold table. So we're going to continue on with our example where we have 150 people with characteristic A and 50 people without. And then we're going to be looking at characteristic B, where some people have characteristic B and some people do not. So we're going to run this data in, pressing Control Enter. If you're on a PC using RStudio, if you're using regular R, you'd press Control R. I'm working in my script up top and my console down below. And then I'm resetting the levels of my factor so that present shows up first instead of doing the automatic alphabetizing. Okay, and then when I look at T, it looks like what we're familiar with, a 2x2 table. And remember, we can get n dot dot, which is the overall sum of T. We can get the row sums in I dots by using our apply function. We can then assign n1 dot and n2 dot accordingly by picking off the first and second element of ni dot. We can get n dot j, which are our column sums using the apply function on the columns. And we can assign n dot 1 and n dot 2 by picking off the first and second element of n dot j. And we can double check to make sure we got n dot 1 and n dot 2 correctly, 25 and 175. Everything's looking good so far. So in 3.2, we get the formula in equation 3.7 for our chi-square test statistic. And we can get this test statistic by following along as so. So Nij, those are all the elements, the N11, N12, N21, and N22. So here are Nij, I have labeled as T. And picking off the ijth element. And then I have the Ni dots and the N dot J's divided by the N dot dot. And essentially this whole piece here is defined in equation 3.8 of our book as capital Nij. I used a for loop here. So essentially this is going to roll through all the different values of I, and it'll roll through the different values of j. And at the end of the day, I'm going to store each of these values in the ijth component of my chi-square test statistic. So prior to setting up my for loop, I'm going to create a matrix with 2 rows and 2 columns. And just to initialize that matrix, I'm going to use the value of 0. Okay, so essentially here, I'm creating a matrix with all zeros. And that will be so that when I run my for loop, I have somewhere to put the values from the for loop. Okay, so running this for loop, I'm going to get all the values that I need for each of the individual pieces within the sum of equation 3.7. All right, from there, I can double check that my chi-square test statistic, the inner values are all the individual pieces. And equation 3.7 just says you need to sum all of those up to get the chi-square value. So I'm going to sum up all of those values to get my test statistic. And I get a value of 2.58, which is exactly what we expected. Now remember, if you don't want to have to run through all those individual pieces of equation 3.7 and 3.8 in our book, you can just use the chi-square dot test function that's already built into R. And we get the same exact value of 2.58 and a p-value of 0.1085. So I hope you learned in this video that you can apply lots of different formulas for the chi-square test. But at the end of the day, it's also built into R. So if you come across a 2x2 table that you need to do a chi-square test for, you can either do it by hand You can do it using the formulas. You can do it through coding in R, or you can use the shortcut. I hope you guys have a great day. Thanks for listening.